Hi, in this video we're actually going to walk through some of the story problem worksheets that I'm going to be giving you. I might have already given them to you a day ahead of time, so as you're watching this video you can be filling this in. We're going to spend a couple days of class, and I know this is the part of algebra that's probably the most frustrating, is setting up story problems and solving. So we're going to try to take some time right now, set some of these up, give you a little bit of an idea of what you need to do, and so when you have class time to work on them, you'll already have had a taste of it and maybe be able to help, put it together. Obviously, what we don't understand, we can talk about more during class time. So there's going to be 4 worksheets, and they're all up here, and I'm going to just pick some of the problems, and we'll just do some of them right now. So let's talk about, first of all, weighted averages. Weighted averages are something that we use a lot, and actually when you calculate our grades in this class, we use what's called a weighted average, so it's good to understand where that comes from. So we have some sample weighted average problems here. 3 different students, and I'm not going to do every one of these, but we'll do at least one of them and maybe go to another page and do another one so you can see weighted averages at work. So this first student here, I'm a brain, she's an Algebra 1, and the course weights for this class were the following. Homework and notes were 20% of the grade, quizzes 30%, and tests 50%. So here's the first thing. If you look at the student's homework and notes, as you can see, they had 5 out of 5, 5 out of 5, 4 out of 5, and 0 out of 5. So let's add those up. They had 14 out of a possible 20 points. The reason I'm getting 14 out of 20, if I add the numbers in the left column, I'm getting 14, and if I add up all the numbers in the right column, I have 20. 14 out of 20, that's 70%. If you put 14 divided by 20 in your calculator right now, you are going to get 0.7. That means 70%. So the person's final grade, they had 70% in homework. Now let's go to quiz scores. 8 out of 10, 5 out of 10, 9 out of 10, and 7 out of 10. Now, there was 4 quizzes, each were 10 points, so I know that there was 40 points possible, and this student had 8 and 5 is 13, and then 16 more. They had 29 out of 40 possible points. So if I take my calculator and I go 29 divided by 40, I'm getting a 72.5% in that category. So I'll put 72.5 here. The test scores. This person had 87, had a good test. They had 87 out of 92, and if I put that in my calculator, I'm going to round that. That works out to about 94.6%. So I'll have to round that one, 94.6. So that would be 94.6. So what I need to do now is weight these averages, because they're not all worth the same. Remember, the homework is only worth 20% of the grade. The quizzes are 30%, and the tests are 50%. So if I just add these 3 percentages up and divide by 3, I'm not going to get the correct grade. I've got to weight them properly. So, and this is exactly what Skyward does to your grade, except my weights are a little bit different. Remember, I have a 5% participation, a 15% homework, 30% quizzes, 50% tests. So I'm kind of close to that. But let's actually figure this out now. In my calculator, I'm going to take 70 times 0.2, because 20% of the grade is my homework and notes, plus I'm going to take 72.5 times 0.3, plus I'm going to take 94.6 times 0.5, and what I'm finding out is that this student had roughly an 83.05 grade when it's all done on weighted average. So this person had a B grade going in this class with that weighted average. Okay, so we'll do one more real quick. Here's a second student, just in time, English 9. Here are the course weights. 20% of the grade was writing, 35% was lit, 35% was grammar, 10% was other. So let's get the averages. First of all, the writing average, remember, it's 20%, lit's 35%, grammar's 35%, and others 10%. Okay, so to get the final grade, first of all, we got to get their individual scores. They had 47 points out of 60. Can you see where I'm getting 47, 45, and 2, and I'm getting 60, 50, and 10? 45 out of 60 is writing. So let me figure out that. 47, I meant to say 47 divided by 60. 47 divided by 60, that's about a 78.3%. Let's go to literature. When I look at lit, they had 35 plus 86 plus 8 plus 16. They scored 145 points when I add up all their points that they got, but there was 50, 100, 60, and 34 possible. If I'm doing that in my head right, you can add it up on your calculator. That's 194. So I got to take 145 divided by 194. That means they had a 74.7% average in lit. Now let's go to grammar. They scored 42 out of 40 points, which means they must have had extra credit. You can see they had more points in the quiz than were possible, so they got extra credit. 42 divided by 40. They had 105% in grammar. And then for other grades, you can see they had 5 out of 5 every time. Well, they had 25 out of 25. They had 100% here. Okay, now let's get their final grade. I got to take 78.3, which is their writing average, but I got to multiply it by the 20%, because remember, that grade is weighted by 20%, so I'm going to multiply it by 0.2. Plus, I got to take the 74.7 that they had in literature, and I got to multiply that by 0.35, because that's 35% of the grade. Plus, I got to take the 105% they had in grammar, and I got to multiply that by 0.35. And finally, I got to take the add on the 100% they had in other grades, and I have to multiply that by 0.1. And this is going to give me their final grade. Let's just put that in our calculator. So I have 78.3 times 0.2 plus 74.7 times 0.35 plus 105 times 0.35 plus I have 100 times 0.1. And if I punch this in my calculator right, and you can verify this on your calculator, I'm rounding this because it says 88.555. I'm going to just round that then. This person had about an 88.6%. They would have gotten a B plus in English 9 when you weigh all these together. Okay? So that's the first part of this worksheet. I'm not going to do the third problem. I'm going to let you try that on your own. And as I scroll down to page 2 or the back side of it, you're going to, there's some other weighted averages. Let me do one of these. When I go to the next sheet, you're going to see some problems just like what we talked about on this sheet that you can try that are weighted averages. I'm not going to do any of those. I'll let you do those on your own. Okay? Let's do one of these weighted average problems here. They give us a little table and stuff, and this is actually a lot easier to figure out if we just use, this is under the umbrella of weighted averages, okay? It's not actual grade calculations, but again, these are like mixture problems. Remember earlier in the year we did mixture problems, and I know you didn't like those. These are, weighted average is another way of saying mixtures. We're mixing in different weights. Your grade is mixed together in different weights, okay? Your test grade isn't an equal weight as your homework or your quizzes. They're mixed, okay? So weighted averages are another way of saying mixture problems. Like look at number 1. They gave you this chart. We don't even need to use this chart. We can now use 2 variables. That's why I'm doing this now. In Chapter 7, remember, we're solving systems. That means 2 variables. If we use 2 variables, we don't even need a chart like this. So think about this. Symphony tickets cost $16 for adults and $8 for students. A total of 634 tickets were sold, worth $8,432. Okay, it says use the table, forget the table. We're just going to use 2 variables. So I'm going to do this. I'll call X my adult tickets, and I'm going to call Y my student tickets. There's definitely 2 equations. First of all, there's a total of 634 tickets. So think about that. If I take the adult tickets and the student tickets and add them together, I'm supposed to get 634. But here's the second equation. These are supposed to add up to $8,432 in tickets were sold. So ready? Every adult ticket is worth $16. It's $16 per adult ticket plus $8 per student ticket, and that's supposed to add up to $8,432. Okay? Let me quickly make a clean page here so we can actually work that out. So I'm going to take that, and I'm going to work it out. So remember, I had x plus y equals 634, and I had 16x plus 8y equals, let me just go back and make sure I had my number right, 8432. This is an easy elimination problem. If I just multiply the top equation by 8, I'll get 8y, and then I can subtract and the 8y's eliminate. So let's rewrite this. So I'm going to rewrite this top equation, multiplying everything by 8. So equation A will now turn into 8x plus 8y equals, let me take my calculator, 634. I got to multiply it by 8. That's 5,072. And equation B I didn't touch, so I didn't change equation B. It's 16x plus 8y equals 8432. I can subtract these equations. So let's subtract. When I subtract, the 8y's subtract away to nothing, but 8x minus 16x is negative 8x, and 5,072 minus 8,432 is negative 3360. Now, I remember when I was your age and I was in high school, I was always like, wait a minute, how can you get a negative answer when you are working with money? But then I remembered, wait a minute, I'm not going to get a negative answer because look what happens when I solve. I got to divide each side by negative 8, and the negatives will cancel out, and I will get a positive answer, so everything is good here. 3360 divided by 8 is 420. We just figured out that we had 420 adult tickets. Well, if there's 420 adult tickets and there's 634 total, all I quickly need to do is take 634 minus the 420. That means there must have been 214 student tickets. So the answer should be 42214. I already know that that works in the first equation. Let's try the second just to make sure. 16 times 420, that's $6,720 in adult tickets, and $8 times 214, that's $1,712 in student tickets. And when I add those together, 6720 plus 1712, I am getting 8432. This worked. Okay? So hopefully that made sense on that one. All right? All right, let's keep on going. Got a couple other sheets here. Okay? Here's another one. These have distance, rate, and time weighted averages. Again, what weighted average means is we're not going the same rate. We're not going could be not going the same time. We got to weight these together using the information given. Okay? So I'm just going to pick one of these. I'm not going to do them all. I'm going to pick one, and we can work it out. And obviously, the ones we're stuck on, we can try more of those tomorrow. So let's try, why don't we try we'll just do number 1 here, okay, because they're all going to be similar. The average speed of a moving van is 24 kilometers per hour faster than that of a delivery truck. If the van travels the same distance as 5 hours as the delivery truck travels in 7 hours, find the average speed of each. Okay, so I would definitely draw a picture of this. Let's draw, first of all, the van. Draw it up here. Here's the van, and the van moves faster than the truck, but they're traveling the same distance. So here's the van's map. I'm just going to draw a distance. Here's how far the van drives. Here's how far the truck drives. So the first thing we know is that these both travel the same distance. Now remember, distance equals rate times time. That's going to be a big key on this sheet. Distance equals rate times time. Now, the van is 24 kilometers per hour faster than that of the truck. So the rate, I have no clue what the truck's rate is. I'll just call it X. There's the truck's rate. I don't know how fast it's going. The van is 24 kilometers per hour faster. So if the truck is traveling X kilometers an hour, the van must be going X plus 24, right? The van travels in 5 hours, so the time for the van is 5. So here's the rate and time of the van. It's rate times time. The truck travels 7 hours. Here's the rate times time of the truck. Now remember, these distances are the same. So does this make sense? Van distance equals truck distance. Well, there's your equation. The van distance is 5 times x plus 24, and the truck distance is 7x. All you need to do is distribute and simplify and solve, and you will find x. Once you find x, you will know the speed of the truck. If you add 24 to x, you'll know the speed of the van. I'm going to let you, I set it up here, I'll let you finish that. Okay? Maybe I should do one more. Okay? Let's just do number 6. And again, I'm not going to do them all. I'm going to let you guys try some of them. I know sometimes trying is a pain in the rear and it gives you a headache and you hate doing it. That's why we got to work through it. I got to make you try to work through some of these, but I'm going to show you some. Okay? Becky and Rita are 648 meters apart. So here's a picture. Here's Becky and here's Rita, and they're 648 meters apart. Becky walks toward Rita at the rate of 2.25 meters per second. So here's Becky, and she's walking toward Rita, and we know her rate. I'll write it up here. It's 2.25 meters per second. Rita runs toward Becky. Okay? So Rita's running, and eventually we know they're going to meet, so I have no clue. I have no clue what Rita's speed is, okay? So I'll call it x. She reaches Becky in 1.6 minutes. Now these are real tricky. We got to be careful here. You notice how they put meters per second here? So this is in seconds. But then over here they're putting minutes. We got to make sure the whole problem is in seconds. So I'm going to change 1.6 minutes. Remember, there's 60 seconds in a minute, so if I take 1.6 times 60, that's 96 seconds. Let me just cross this out. This is 96 seconds, okay? So let's think about it. If it takes 96 seconds for Rita to reach Becky, that means when they both started, think about this. They're both going to start here, and I say go, and I start the stopwatch. When they reach each other here, they both walked 96 seconds, or at least ran, respectively. So Becky must have walked 96 seconds, Rita ran 96 seconds, because they both started at the same time. So here's the thing. Does this make sense? Becky's distance here, the distance Becky walked, plus the distance Rita ran, if I take Becky's distance plus Rita's distance, they have to equal 648. So let me write that down. Becky's distance plus Rita's distance has to equal 648. Well, Becky's distance, remember, distance equals rate times time. Becky's rate and time are right here. Her rate was 2.25, and her time was 96 seconds. Rita, her rate was x, and her time was 96. All you need to do is simplify and solve that equation, and once you find x, you will find Rita's average speed. Okay? So I'm not going to do another one on that sheet. I think that's good there. Okay? These problems here are similar to those. I don't know if I'm going to do one of those either. Well, maybe I will do just one. Okay? These problems are kind of cool because they have you consider wind speed and things. So let's look at this one. Let's go to number 3 on this sheet, because this has us consider not only distance, rate, and time, but it also considers flow of a current. Rose took a half hour to row 3 kilometers with the current. So she's in a stream. So here's the stream. Here's Rose. The stream is flowing in this direction. Okay, and she's in her canoe, and Rose is going the same direction as the stream. So does it make sense that if she's rowing with the stream, she's going to go faster? She's getting the stream moving with her. Her time was a half hour to row with the stream. Okay? Now on the way back, it took an hour and a half. Look at that, 90 minutes. It took an hour and a half, because now on the way back, the stream is still flowing in the same direction, but she's rowing against the stream, so obviously that's going to slow her way down. Okay? So the time back is an hour and a half. Okay? So now what we want to do is when she returns, it was 90 minutes, find her rowing rate and the speed of the current. Now here's the thing, okay? Her rowing rate would be the same, okay? If you think about her rowing, the amount of paddling she's doing, or the speed of paddling isn't changing either way. What's changing is the rate of the stream, okay? So here's the thing. Her paddling rate is X. The stream is moving at a rate of Y. So on the way there, think about this. Her speed would be taking her rate of rowing plus the rate of the stream. There's her rate. And if you multiply by the time, which was half an hour, remember, distance equals rate times time. So her distance there would have been this rate with this time. But on the way back, her rate is different. She's still rowing at X. She's still doing the same rowing speed, but now the current works against her. So her speed now is her rowing minus the stream, because the stream is slowing her down, and here's her time. Now remember, the distance there, let me write this down, the distance there would equal the distance back. Well, distance there would be rate and time. Here's the distance there. Okay? And here's the distance back. All we need to do is solve this system. Now we have two variables here. We've got to solve the system to solve this. So maybe I'll just do this one with you. We'll just solve it. So let's distribute 0.5x plus 0.5y equals 1.5x minus 1.5y. Okay? And then what I can do here is, since these distances are the same, and hold on, I missed something here. I screwed one thing up. They told me both distances were 3 kilometers, so timeout. I screwed one thing up here. I don't want to do this. My bad. Okay? What I should have done is each of these equaled 3. Okay? I just wasn't thinking here. Okay? Each of these are 3 kilometers, right? The distance there is 3 kilometers, the distance back. So the distance there is 3, distance back is 3. So let me go back and rewrite that again. I apologize I wasn't thinking there. I had a brain cramp, my bad. Okay? So I have two variables. I need two equations. That should have been my first clue that I screwed up earlier. If you have two variables, you need two equations. You need a system, and I was just writing one equation. So distribute. So here's equation A. I get 0.5x plus 0.5y equals 3. And then the second equation, I get 1.5x minus 1.5y equals 3. Do you see a system here? You can either use, well, I'd probably use elimination. If you multiply the top equation by 3, do you notice that, well, I have 1.5x and 1.5x. I could subtract, for example, and the x's will eliminate, but the y's will not. And I can solve for y and solve for x, and I'll have it. Okay? So I think I'm going to stop on that one there. I'll let you finish that one up. But that's how we would work these problems where we're going against, like, you look at these, you're either going to be like a plane flying with the wind, flying against the wind, that type of thing. Okay? And then one more, maybe we'll just look at one more example if we have one. Let's do one with, well, here's one with coins. You can use two variables to solve coin equations. Earlier in the year, we were using them to solve one. Lisa has 40 bucks in coin, or 40 coins, I should say, worth $8.80. Some of the coins are nickels and some are quarters. How much of each coin does she have? Well, we'll call the nickels X and the quarters Y. Well, first of all, she has 40 coins. X plus Y should equal 40. But she also has $8.80 in coins. So remember, nickels are worth 5 cents. It's 5 cents for every nickel plus 25 cents for every quarter, and that should equal $8.80. Well, there's a system. You can, if you wanted to, you could multiply the first equation by 0.05, and you'd be able to eliminate the x's by subtracting, and then you can solve. Okay? I think I'm going to stop this video here, so I'm already at 25 minutes. I know you don't like these going on forever, but I try to do a little bit of each worksheet just to give you a good start. And I'm going to give you a couple days to work on these worksheets. We'll do a couple in class one day, a couple of the other, and we can talk through these too if we get stuck. Okay? So I'm going to stop this here.